Welcome! In this course, we don't treat calculus as a set of isolated problems to solve for an exam. Instead, think of it as the fundamental operating system that runs almost every technical field. When a civil engineer designs a suspension bridge, the elegant curve of the cable isn't guessed, it's derived from calculus, balancing forces at every single point. When a data scientist trains a neural network, the learning process itself is an application of derivatives, gently nudging the network toward accuracy. And when a game developer makes a character jump, the smooth, realistic arc through the air is a direct translation of an integral. You are not just learning abstract symbols, you are learning the precise language that describes how things change, accumulate, and relate to each other in the physical and digital worlds. This foundation you're building is the first step toward fluency in that language. Let's break down why this matters so deeply. The derivative is your tool for understanding an instant. Imagine a satellite. Its velocity isn't constant, and we need to know its exact speed at a precise moment to adjust its orbit. That's a derivative. The integral, on the other hand, is about accumulation. To predict the spread of a virus, an epidemiologist doesn't just count cases daily, they use integrals to model the total number of infections over time from a rate of change. The magic is that these two seemingly different operations, finding a rate and finding a total, are intimately connected by the fundamental theorem of calculus. This connection is the core insight you'll master. When you solve a problem about a particle's motion, you're not just manipulating equations, you're directly simulating the logic a physicist uses to track a particle in a collider or an engineer uses to optimize a delivery drone's battery life by modeling its changing energy consumption. So, as we move forward, carry this perspective with you. Every limit, derivative, and integral you learn is a new verb in the language that runs the modern world. When a formula feels abstract, ground it. A derivative isn't just a slope, it's the exact steepness of a bridge cable at a point, preventing a collapse. An integral isn't just an area under a curve, it's the total distance traveled by a character in a game, ensuring their jump feels perfectly real. Your goal in this course isn't just to pass the IIT-JEE, though that is a crucial milestone. It's to build a genuine, intuitive grasp of calculus that will serve as the bedrock for any engineering or science career you choose. You are building a mental toolkit that will let you design, predict, and optimize systems for the rest of your life. Let's begin building that toolkit, one clear concept at a time. In our last session, we saw calculus as the silent engine behind so much of modern life. Today, we zoom in on exactly what makes it tick. Algebra is brilliant, but it stumbles on two specific, crucial problems. First, it can only give you an average speed over a trip, never the exact speed at a single, frozen moment when a speedometer needle is moving. Second, it cannot handle the total volume of a shape that is constantly changing, like a pool with curving walls. Calculus steps in with two distinct superpowers to solve these. Think of this chapter as handing you the keys to the entire subject. For your IIT-JEE preparation, understanding these two core problems isn't just helpful, it's the foundation upon which every derivative and integral problem is built. We are not just learning procedures, we are learning them why that makes the procedures work. Let's dive into the first superpower. Imagine you are in a car, and the speedometer needle is sweeping upwards. Algebra divides the total distance by total time to say you averaged 60 kilometers per hour. But what was your exact speed at the precise instant you passed a milestone? To answer that, calculus does something audacious. It shrinks the time interval over which we measure change until it is infinitesimally small, approaching zero. This process gives us the derivative, a tool to measure an instantaneous rate of change. Now, the second superpower. Picture a swimming pool with a beautifully curved, free-form shape. You need to fill it and know the exact volume of water. Algebra's simple length times width times height formula is useless here. Calculus instead slices the pool into infinitely many, infinitely thin horizontal disks, each with a slightly different radius. By summing the volumes of all these tiny slices, a process called integration, we get the exact total volume. So, what should you carry forward from this chapter? First, a clear, confident answer to the question, what is calculus for? It is the mathematical toolkit that gives us the exact speed at a single moment and the exact total of something that builds up in constantly changing pieces. These are the two superpowers. Every time you see a derivative problem in your IIT-JEE practice, I want you to mentally picture that speedometer needle and the idea of capturing a single instant. When you face an integral, visualize slicing a complex shape into manageable, vanishingly thin pieces and summing them up. This mental framing will prevent you from getting lost in mere symbol manipulation. The entire course from here on is an exploration of these two ideas and their profound connection. Your immediate task is to start training your eye to spot these two core problems in the physics and geometry you already know. That is the first step to true mastery. Let's be honest about what makes calculus feel so intimidating. You might think it's about memorizing a mountain of formulas, or that you need some specialist math brainer to get it. There's also that sinking feeling that if you mess up one step, you'll be lost forever. But here's the truth we've seen with countless students: the real struggle almost always comes from shaky foundations in algebra and trigonometry, not from the calculus concepts themselves. Think of it like trying to build a house on a wobbly, cracked foundation. The walls will crack no matter how carefully you place the bricks. In this course, we'll show you that calculus is actually built on a small set of powerful, intuitive ideas that we apply again and again. Once your foundation is solid, those ideas become clear and even beautiful. When you're staring at a limit problem and feeling stuck, it's rarely because the idea of a limit is too hard. More often, you're wrestling with factoring a polynomial, rationalizing a numerator, or simplifying a complex fraction, all algebra skills. When derivatives feel confusing, look closely. Are you comfortable with exponent rules, or rewriting a square root as a power? For integrals, the real test is often your ability to recognize trig identities or decompose a rational expression. This is actually great news, because these foundational skills are completely fixable. Picture that student who reinforces their shaky foundation. They dig down, strengthen the concrete, and then watch as the same house that once wobbled now stands firm and secure. That's exactly what we'll do together in this module. So let's reframe that fear. It's not a sign that you're bad at math, it's a helpful signal pointing to exactly where your foundation needs a little reinforcement. In this course, we've designed the Calculus Foundations module specifically to help you diagnose and repair those algebra and trigonometry gaps before they cause trouble. As you move forward, try to see calculus not as a scattered list of tricks, but as the two superpowers we discussed earlier, rates of change and accumulation, expressed through a consistent set of principles. Every new topic will connect back to these core ideas. Trust the process, use the practice problems to solidify each layer, and remember, you are absolutely capable of building a rock-solid understanding that will serve you brilliantly in your IIT-JEE preparation. Welcome back. In the earlier parts of this lesson, we talked about calculus as a silent engine and its two superpowers, and we addressed why fear often comes from a shaky foundation. Now, let's dismantle that fear completely. The truth is, you've already been doing calculus in disguise throughout your class 11 and 12 math. Remember studying rational functions and their asymptotes? You were essentially exploring limits, finding the value a function approaches without ever necessarily reaching it. Similarly, the slope formula from coordinate geometry, the one you use to find the steepness of a line, is the direct ancestor of differentiation. Even the idea of a secant line getting closer and closer to a tangent line is something you've likely visualized when studying circles or parabolas. This section is about building that hidden bridge, showing you that calculus is not an alien invasion but a logical, beautiful extension of the tools you already own. Let's make these connections explicit. First, limits. When you analyzed a function like 1 over x and said its graph approaches the x-axis but never touches it, you were describing a limit. Calculus simply gives you the notation and rigor to say exactly what value that function is heading toward. Next, differentiation. You know the slope formula, change in y over change in x. That works perfectly for straight lines, but what about a curve whose steepness is constantly changing? The derivative is the answer. It takes that same slope formula and shrinks the interval between 2 points until they essentially become 1, giving you the instantaneous rate of change. This is exactly the visual of a secant line rotating and morphing into a tangent line as the 2 points of intersection merge. Finally, integration. Once you learn how to find a derivative, integration is simply asking the reverse question: if you know the rate of change, what was the original function? It's the antiderivative, completing the pair. So, as you move forward into this Calculus Foundations module, hold on to this perspective. The fear we discussed earlier often stems from seeing calculus as a completely new, abstract mountain. But now you see it's a hill you've been climbing for 2 years. Limits are just a precise language for approaching values you've already encountered with asymptotes. Differentiation is your trusted slope formula, supercharged to work on curves. Integration is the natural undo button for differentiation. Whenever you feel lost, bring back that mental image of the secant line slowly rotating and snapping into the tangent line. That single visual encapsulates the entire leap from algebra to calculus. You are not starting from scratch. You are simply learning the formal names and methods for ideas your mind already grasps. Walk into this chapter knowing the bridge is solid, and you built it yourself. Welcome back. Earlier, we explored how calculus is a silent engine and why the fear around it is often based on a misunderstanding. Now, we confront a critical trap in IIT-JEE preparation: the belief that solving thousands of problems by pattern matching is enough. The exam is designed to shatter that illusion. Today, we'll dissect a specific problem that looks like a standard derivative application but contains a subtle domain restriction. We'll visualize 2 students, one armed with 200 memorized formulas who freezes, and another who deeply understands the chain rule and calmly deconstructs the challenge. This isn't about knowing more formulas, it's about cultivating a problem-solving instinct by always asking what the function is truly doing before you ever reach for a rule. This shift is what transforms a struggling student into a confident one. Let's dive into our key example. Consider a problem asking for the derivative of a function like the natural log of an expression that looks factorable, but inside, it contains a square root of a negative quadratic. Student A, who has memorized 200 derivative formulas, immediately sees the outer log and inner fraction and starts applying the chain rule mechanically. They write down a derivative that is mathematically invalid for most real numbers because they never check the domain where the original function even exists. They freeze when their answer doesn't match the options. Student B, who truly understands the chain rule as a way to unpack nested changes, pauses. Their first instinct is to ask, for what x is this function even defined? They simplify the expression using logarithm properties, revealing a hidden domain restriction that completely changes the derivative. This student calmly deconstructs the problem from the inside out. So, what do we carry forward from this? The trap we exposed reveals a fundamental truth: IIT-JEE calculus is not a speed test of formula recall, it's a test of your mathematical maturity. Rote practice creates a brittle skill that shatters the moment a problem deviates slightly from a familiar template. True preparation means building an adaptive instinct. From now on, in every problem you face in this course, make one habit non-negotiable. Before you pick up a calculus tool, put on your detective hat. Ask, what is this function's story? Where does it live? Can I rewrite it more honestly? Use the algebra and trigonometry you already mastered, the hidden bridge we discussed earlier, to simplify the problem at its core. When you do this, you're not just solving a problem, you're building the calm, deconstructive mindset that turns a seemingly impossible JEE question into a series of logical steps. This is the true superpower of calculus. In the earlier part of this lesson, we talked about how calculus is the silent engine of our world and how fear often comes from not seeing its real meaning. Now we take the most important step, making it yours. Interest in calculus is not something you either have or don't have before you start studying. It grows naturally when you begin to recognize the two superpowers, differentiation and integration, in your own daily life. Think of this as becoming a calculus detective. You'll start spotting rates of change and accumulation everywhere, from the curve of a water fountain to the way your phone's camera works. This isn't about labs or special equipment, it's about training your eyes to see the math that is already there. When you do that, the subject stops being a set of rules to memorize for IIT-JEE and becomes a language describing your world. That shift is what builds genuine, lasting interest and deep understanding. Let's make this concrete with 3 everyday scenes that require nothing but your attention. First, watch a water fountain. The stream forms a beautiful parabola. At any single point along that arc, the slope of the curve tells you how steeply the water is rising or falling right there. That slope is the derivative, the instantaneous rate of change of height with respect to horizontal distance. Second, think about your phone's face unlock or video stabilization. Your hand shakes, sending noisy, jittery data to the camera. The software doesn't just take one shaky frame, it gathers many tiny position readings over a split second and mathematically smooths them into one stable image. That process of collecting and combining tiny bits of information to get a whole, stable result is integration in action. Third, imagine a rumor spreading through your classroom. One person tells 2, those 2 each tell 2 more, and soon the whole class knows. Starting today, adopt the identity of a calculus detective. As you move through your day, actively ask yourself 2 questions: where is something changing, and how fast is it changing right now? Where are small bits adding up to make a whole? When you see a car accelerating from a signal, mentally note that its speed is the derivative of its position. When you watch rain fill a puddle, see integration at work. Say these observations out loud or write them down. Then, when you sit down to study the formal concepts in this IIT-JEE course, you won't be meeting them for the first time. You'll be giving names and precise mathematical tools to things you've already witnessed. This directly fights the trap we discussed earlier, rote practice without real understanding. The JEE doesn't just test your ability to apply formulas, it tests your deep, intuitive grasp of concepts in new situations. That grasp comes from this kind of personal connection. Welcome back, detective. In our last session, we exposed the IIT-JEE trap of rote practice versus real understanding. Now let's replace that trap with a workflow that respects how your brain actually learns. Think of studying calculus not as a one-time download, but as painting a wall. One thick coat drips, cracks, and peels. 3 thin, patient coats create a deep, durable finish. The first coat is pure conceptual understanding, watching an animation of a limit, sketching your own secant lines approaching a tangent, and explaining the idea to a friend in plain Hindi or English. The second coat is guided problem solving where you keep the full solution open, follow the logic, and absorb the structure. The third coat is timed, independent practice, no peeking. And here is the most important shift: when you hit a wall for 15 minutes on a problem before seeing the solution, that is not failure. That is the exact moment your brain is laying down new neural wiring. Let's break down each coat. For the first pass, after you watch a course animation on, say, the limit definition of a derivative, do not just nod along. Pause it. Grab a notebook and draw your own version of the graph, labeling the shrinking interval yourself. Then turn to a friend, or even your phone's voice recorder, and explain what happens as delta x approaches 0, using the simplest words possible. This forces you to own the idea, not just recognize it. For the second pass, open a problem set but keep the step-by-step solution right beside you. Read a line of the solution, then ask yourself why that step was taken. You are not copying, you are reverse engineering the thinking of an expert. This builds the bridge from your Class 11 algebra and trigonometry to calculus fluency. For the third pass, close everything. Set a timer and attempt a fresh problem. This is where the real detective work happens. So, as you move forward in this Calculus Foundations module, I want you to adopt this three-coat rhythm as your default study strategy. Before you ever touch a practice problem, build the mental picture. Before you test yourself, walk through solved examples with the curiosity of a detective examining evidence. And when you finally sit for timed practice, treat it not as a judgment of your worth, but as an honest mirror showing you which layer needs another coat. Remember, the two superpowers of calculus, differentiation and integration, are not conquered in a single all-nighter. They are absorbed through this patient layering. The fear we discussed earlier dissolves when you realize you are not supposed to get everything right on the first try. That 15-minute struggle is the hidden bridge between rote practice and real understanding. Paint your wall carefully, coat by coat, and you will walk into your exam with a depth of knowledge that no cramming session can ever provide. In this lesson, we tackle what might be the most underrated skill in your entire JEE preparation: the ability to move fluidly between a graph, its equation, and what it physically represents. This isn't a standalone topic you'll find in a textbook index. Instead, think of it as the thread that sews together everything we've discussed so far, from the two superpowers of calculus to the detective mindset. When you look at a position-time graph and instantly see where velocity is positive, 0, or changing, you're not just doing kinematics, you're living the connection between a function and its derivative. The JEE frequently designs questions that test exactly this: can you look at a graph and infer the function's behavior, or look at an equation and sketch its essential features? This skill transforms calculus from a collection of rules into a single, coherent story. By the end of this section, you'll see why dedicating focused time to this translation is not a detour but the most direct path to deep understanding. Let's build this fluency step by step. First, internalize that the slope of a graph at any point is exactly the value of its derivative at that point. On a position-time graph, a steep upward slope means high positive velocity, a flat slope means the object is stationary. Now, take this further. Imagine a small bump appearing in your function. That bump forces the derivative to cross 0, going from positive to 0 at the peak to negative. This is the visual root of why a function's increasing or decreasing behavior is tied to the sign of its derivative. Next, flip the relationship. The area under a velocity-time graph between two moments gives you the net displacement. This is the fundamental theorem of calculus in action, not as an abstract symbol but as a physical story. As we wrap up, remember that this translation skill is your secret weapon for conquering the JEE calculus section. From now on, whenever you encounter a new concept, whether it's a limit, a continuity condition, or an integration technique, make it a habit to ask, what does this look like on a graph, and what physical meaning could it carry? This simple question activates the detective mindset we've been cultivating and prevents you from falling into the rote practice trap. The beauty is that this isn't extra work, it's a more efficient way to study. One well-chosen dynamic visualization, where you see a function, its slope, and the area under its curve all linked on one screen, can clarify ideas that might otherwise take dozens of isolated problems to grasp. Carry this fluency forward into every remaining module of this course. When you master the art of translating between graphs, equations, and physical meaning, calculus stops being a collection of intimidating formulas and becomes a powerful, unified language you can read fluently. Let's be honest, preparing for the JEE is one of the hardest things you'll ever do, and feeling lost in calculus is completely normal. But here's what makes calculus different from other subjects you're tackling. It's built like a chain where every theorem rests on a previous one. This means that unlike memorizing disconnected facts, your understanding actually compounds over time. Think of a mountain that looks impossibly steep from the bottom. As you get closer, you discover it's crisscrossed with manageable switchbacks. That's exactly how calculus works. The initial view is intimidating, but the path reveals itself step by logical step. Every single topper who now solves complex integrals effortlessly started exactly where you are right now, staring at limits and wondering if they belong in this race. I want you to really internalize this. The toppers you admire were once just as confused by the epsilon delta definition of a limit as you might be right now. They felt the same knot in their stomach when they first saw a page full of integral symbols. The single factor that separated them wasn't some innate math gene. It was their stubborn refusal to just memorize formulas and move on. They kept asking, why does this integration technique work, and where does this formula actually come from? By doing this, they were essentially laying down the switchbacks on their own mountain path. Each genuine question you ask and resolve, no matter how basic it seems, is you doing the same thing. You're not falling behind when you ask why, you're building the only kind of understanding that survives the pressure of the JEE exam hall. Your anxiety will try to convince you that you're running out of time, but the logical structure of calculus is actually your greatest ally. Because each concept genuinely supports the next, the time you invest in truly understanding limits will pay you back tenfold when you reach continuity and differentiability. You won't need to relearn everything from scratch. The confusion you feel right now isn't a stop sign, it's the mental friction that precedes a breakthrough. So, as you continue with this course, make a pact with yourself. When you encounter a new theorem, channel your inner detective from our earlier discussion. Ask why it's true, not just how to apply it. Visualize that mountain path. The switchbacks are there. You are not alone on this climb, and you have more time than you think to reach the summit with a solid, unshakable understanding.